So the other part is transient and surge protection. While we were talking about conducted emissions, we were talking about EMC part of it. Now let's talk about immunity of power supplies. And immunity of power supplies most commonly relates to transient and surge protection. The difference between transients and surges is that transients are short in duration, so those would typically be very fast and high spikes on mains voltage, which are quite similar to ESD spikes that we would get from let's say just touching a microcontroller, and I talked a lot about ESD in another video. The transients on voltage mains typically have different source of origin though, as they would normally come from either a noisy power supply that generates a lot of inrush current, or they would be just present on the mains because of cable dragging and things like that. Then we also get long surges, and those kind of surges would typically be related to electricity generation in general, and especially in rural environments that is quite a common problem. In that case, the overvoltage condition will last a significant amount of time, and we cannot just clamp it because we will overheat our clamping circuit. So in that case, we really need to detect the overvoltage and switch off our device, and this is basically the best thing we can do unless we have a dedicated box with a dedicated heatsink for basically clamping this voltage to a suitable level. So how do we protect our system against voltage surges and transients? Well, the main part for this would be a varistor, which would look something like that. And what a varistor does is that it clamps voltage to a sensible level from a transient spike, which could be up to 6 kV sometimes, and it kinda acts like a TVS diode. So let's go back to our printed circuit board example. So in this example we actually have two varistors, one for AC and another one for DC. So together they provide a really good protection against all kinds of transients. The other thing that you can do is you can limit inrush current by adding a thermistor, and this is another quite commonly used part. What a thermistor is a resistor that varies with temperature. So when the power supply is first plugged in, there is a high potential of an inrush current going through the system, but at this time the thermistor is cold, so it will have its maximum resistance, which in this case is 2.5 ohm. As the current starts flowing in, it's going to limit the initial spike, but the thermistor will get hotter and hotter, and as the thermistor gets hot, its resistance will drop to almost 0 ohm. So at this point it's not going to influence the system quite as much, and it will stop limiting current. But the thermistor is a lossy component, as it will always dissipate heat. So in this example we also have a power relay, and the job of power relay is to short out the thermistor as soon as the voltage output of the switch mode power supply is stable. Finally, if the voltage surge is severe enough and it doesn't go away, what we use is a so-called crowbar circuit. And what a crowbar circuit does, it shorts out the power supply in the event of a continuous surge or an overvoltage condition, and it will do that until the overvoltage condition is gone. So this is another essential part of a switch mode power supply schematic, and if you do not see that in your switch mode power supply, you should definitely consider adding it or talk to someone about it. The only thing that I haven't talked about on this circuit is a Capacitor IC, and what it does, it discharges capacitors, both X and Y's, so that when you touch mains by accident, for example immediately after unplugging the IC connector, then you're not gonna get any kind of shock or uneasy feeling, which you would get if you didn't have this IC. So this is basically the only kind of purpose that it has. I hope you enjoyed this video and you learned a little bit more about how to select line filters and common mode chokes, as well as how to protect your power supply against transient voltages and surge voltages. Please let me know if you would like me to cover something in more detail than I did here, and I'll try to do that in near future. For now, please like and subscribe, and I'll see you in the next video.